good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We are continuing today with 9.4. We're simplifying radical expressions using properties of radicals now. And we were on example C here, or example 3C. Example 3C. So let us continue here. First of all, okay, give me 1 second. We're having a problem here. Am I on the right question? Okay, thank you very much, guys. Okay, thank you. Now, if you guys remember, we have in order to multiply radicals, they have to be like radical roots, okay? They have to have the same roots. So this is the cube root and the cube root. There's an invisible 1 outside of this radical, so 3 times 1 is 3. The cube root of 4x times the cube root of 2x to the 4th is going to be the cube root of 8x to the 5th. Does that make sense? Now, I can go ahead and reduce this. What's the cube root of 8? So 2 times 3 is 6. What's the cube root of x to the 5th? 1x comes out, and I have a cube root of x squared left over. Does everyone see how I did that? Because I didn't really show the work here. What I did was I said, okay, the cube root of 8 is 2. That one's easy. 2 times 3 is 6. Remember, 3 goes into 5 one time, so I pull out one set of 3. What do I have left over? 2 x's that are inside that cube root. Does that make sense, please, to everybody? Okay, thank you very much. How did I get the 6? What's the cube root of 8, my brother? 2. What's 2 times 3? Bam. Thank you, sir. Okay, next. 4 cube root of 8n squared m to the 5th times cube root of 6n squared m to the 4th. Okay, it's going to be a 4 out here because there's an invisible 1 out here, so 4 times 1 is 4. Cube root, I can multiply them. So I'm going to have 48 n to the 4th m to the 9th. Because when I multiply the same base, I add the exponents. Okay, cube root here. What kind of cube roots can I take out of 48? 4 is not a cube root. But 8 is. 8 times 6 is 48, correct? Does everyone see that? Remember what I told you guys. You guys got to know your square roots, your cube roots. It really helps. How many times? What's the cube root of 8? What's 2 times 4? Okay, so we got an 8 out here. Bye-bye. I got a cube root of 6 left over already. Does that make sense, everybody? You promise? What's the cube root of n to the 4th? 1n comes out. How many are left in? All right, excellent. Cube root of m to the 9th? M cubed comes out. Nothing left over. I am done. Does that make sense to everybody? Do you see the logic here? Remember, we're looking for sets of 3 or cube roots. Every time you could recognize a cube root, take it out. Anytime you see a set of 3, take it out. Why do we leave the 6 inside? Because 6 breaks down to 2 times 3. There aren't 3 3s. There aren't 3 2s. There aren't 3 6s. So I have to leave it inside. I cannot form a set of 3 to pull out. Make sense, guys? All right. Move on. Now, division. Division is the same concept. You can only divide radicals that contain or that have the same root. Okay? If the nth root of a divided by the nth root of b are real numbers, and b is not equal to 0, hint, hint, b cannot be equal to 0 because if it's equal to 0, it's undefined. We already know that. If b is not equal to 0 and it is an integer, then the nth root of a divided by the nth root of b can be formed into one big fat nth root of a over b. You can combine them or simplify them separately. But sometimes combining them makes your life a lot easier. For example, the square root of 18 to the 5th divided by the square root of 2x cubed. Well, since they're both square roots, I can put this into one giant square root of 18x to the 5th over 2x cubed. Now let's divide within the radical. 18 divided by 2 is 9. X to the 5th divided by x cubed is x squared. Oh, this makes it a lot easier. My answer is 3x. Are there other ways to do this, Mr. Morrow? Yeah, sure, of course. That's the easiest. Okay? Now, for those of you who think sometimes a little bit differently or outside of the box, you may be thinking this. Wait a second, Morrow. Can't you take this out right now, this one right here, and say, I can break this up into 9 times 2. The square root of 9, Mr. Morrow, is 3. Right? You guys with me? And I have a square root of 2 left over, right? What's the square root of x to the 5th? X squared. And I've got an x left over, right? Okay. 2x cubed. The square root of 2 is going nowhere. What's the square root of x cubed? No, just x. And then I have 1x left over. What's the square root of 2x divided by the square root of 2x? Bam. X squared divided by x? Bam. You could do it that way as well. But as you see, it's a lot more work. But I don't want to discount that from you. You are able to do that. But it is a lot easier. Hopefully you agree. 18x to the 5th over 2x cubed. Oh, wait a second. That's 9. Bam. That's x squared. And then boom. It's a lot quicker. A lot easier. A lot more to the point. Okay, letter B. Cube root of 162y to the 5th divided by cube root of y of 3y squared. Cube root of 3y squared. Let's take one giant cube root. And let's go 162 y to the 5th divided by 3y squared. Okay. What's 162? Wow, perfect. Thank you, my brothers. It's 54. 54y cubed. Okay. Can you think of a perfect cube? Okay, 9 and 6. Think about this. That's not a perfect cube. 27 and 2. Yes. Guys, let me just show you. Just so you see. 9 and 6 were perfect. That would have been a 3 and a 3. That would have broken down into a 3 and a 2. That works. 1, 2, 3 threes comes out as a 3. I've got a cube root of 2 left. Cube root of y cubed is y. Boom. That totally would have worked. However, wouldn't this have been easier? I'm at this stage again. Cube root of 54y cubed. 27 times 3. What's the cube root of 27? 3. I'm sorry, times 2. Pay attention, Morrow. 3, take out the y, and I've got a cube root of 2 left over. It really doesn't matter to me. And eventually, you will start seeing these perfect cubes. But I just want to show you, you can break it down. The concept stays the same. Depending on the root, you need a set of that many numbers to pull out one value. Okay? You have a 5th root, you need, for example, 5 5s to pull out a 5. Or 5 2s to pull out a 2. You have a cube root, you need 3 2s to pull out a 2. Or 4 4s to pull out a 4, etc., etc. Does that make sense? Okay. Next. Now in this case, there's a good one. In this case, I'm starting as one whole value. But can I reduce 6 and 125? So in this case, the opposite seems to work. 6z cube root of 6z cubed over cube root of 125. Ah, this may work out better. What's the cube root of y cubed? Of z cubed, rather. Z times the cube root of 6 over, what's the cube root of 125? 5. Done. So sometimes it behooves you to combine them into one. Sometimes it benefits you to separate them. Does that make sense? I'm going to erase this stuff here. Go ahead and start with this guy now. Okay, in this case, what do you think? Should I put them together or what? Put them together for sure because I can divide 54 by 2. So I've got the cube root. 54 divided by 2 is 27, right? 27, the numerator. But what's x divided by x to the 4th? X cubed. Very good. Very good, brother. Nice job, man. So this is going to be, what's the cube root of 27? Okay, so that's going to be negative 6 over, what's the cube root of x cubed in the denominator? Bam. Does that make sense? You promised me. Okay, awesome. You guys are great. All right. Cube root of negative 375x squared y over the cube root of 3x to the negative 1 y to the 7th. Let's definitely put this together. Let's see what kind of simplifying we could do. We're going to have 375x squared y over 3x to the negative 1 y to the 7th. Let's first clean up the variables here and let's reduce. What's 375 divided by 3, my brothers? 125. Done. Negative. Thank you, son. Thank you. What's x squared divided by x to the negative 1? X to the 3rd, right? Because don't I bring this guy up? So that's x cubed up here. Bless you. And then what's y divided by y to the 7th? Y to the 6th in the denominator. Now this is a lot prettier. What did I tell you about a negative and an odd root? Take out the negative immediately because that's a negative 1. The odd root of any negative is negative 1. So I'm going to have a negative. What's the cube root of 125? So I got a negative 5. Cube root of x cubed. And cube root of y to the 6th in the denominator is y squared. Boom. No leftovers. I'm done. I am done. Does that make sense? Talk to me, guys. Yes, thank you, sir. You sure? Yeah. Okay. All right, let's do this. 4th root of 10x squared over 81y to the 4th. Okay, this is a good one. Okay, let's see what we got. I'm going to split this up. I'm going to have 10x squared up here. And down here, I'm going to have the 4th root of 81y to the 4th. 81, can we think of any perfect fourths? 3, I love it. Great job. And what's the 4th root of y to the 4th? Nothing can be simplified up here at the top. So it's the 4th root of 10x squared over 3y. Fantastic. Except, did I pull out an odd from an even root? So y has to be an absolute value. Y is not equal to 0 has already been given to you. Did that make sense? What happened there, guys? Anytime you pull an odd exponent out of an even root, it must be an absolute value. Now, in this particular case, we're out of luck. We're out of luck here, guys. Even if I go to exponential, this is 8 to the 1/4 times 5 to the 1/3. I can't do anything here. You can't do anything. That's bye-bye. Nothing to be done here. Does that make sense? Yes, sir. Yeah, this would not be possible. You go, not possible. It's not a no solution because it's not an equation, but that's not possible. It does not have the same roots. So you cannot multiply those. Does that make sense? H. It's tempting. Because you're like, yeah, 5 times 2, Mr. Morrow. Yeah, but so what? You don't have the same base here, first of all. And you don't have the same root. This is 10 to the 1/2 times 5 to the 1/3. I can't do anything there because my bases are different. If I had the square root of 5 times the cube root of 5, oh, then I could do something. Then I could change this to 5 1/2 times 5 1/3. We already know how to do that, and you add the exponents. But in radical form like this, you can't do anything. Without the bases the same, you can't do anything. So that's not possible. Does that make sense, guys? All right. Thank you very much. You got a question? No? Okay. All right. Awesome. I'm going to hit pause real quick and put up 9-5. So let's go. Get ready. All right, guys. Let's continue here with 9-5, which is adding, subtracting, and a little bit more of multiplying radical expressions. We already multiplied radical expressions. And remember that when we multiply radical expressions, they must have the same roots. However, for adding and subtracting, okay, you can only add and subtract like radicals. What are like radicals? Like radicals are radical expressions that have the same index and the same radicand. Okay, so again, you must have the same index and the same radicand. It's very similar to like terms. Remember, you can add 2x plus 5x, that's 7x's. But you cannot add 2x squared plus 5x because they don't have the same exponent. Same thing here. You have to have like radicals. Same radicand, same root or index. If you don't have that, you can't do anything. Here, 3 square roots of 5, that's the way I read it. So I can recognize what kind of radical I'm dealing with. So I see this like dice or apples or pears. I got 3 square roots of 5 minus 2 square roots of 5. How many square roots do I have? Square roots of 5. I have 1 square root of 5, x. Does that make sense? Because 3 of these minus 2 of these, I only got 1 left. B, 6x squared square root of 7 plus 4x square root of 5. I can do nothing with this. It's not possible. Why? Why, Mr. Moore? They're both square roots.
Are there going to be a lot of questions when it's not possible?
Are there going to be a lot of questions that are not possible? No. Maybe. Yes. I don't know. You have to be prepared for anything. But I was hoping you were talking about this question. Yeah, the answer here is not possible because, not because they're both square roots, but because the radicands are not the same. I could have multiplied these, right? If I wanted to, bless you. If this was multiplication, this would have been 24x cubed to the square root of 35, right? Right? But we're not multiplying. We're adding. So it's not possible. Okay. Next. 12 cube roots of 7xy minus 8 fifth roots of 7xy. Now, no. Different root, not possible. I'm just going to put MP. B, 17 fifth roots of 3x squared minus 15 fifth roots of 3x squared. This will be 2 fifth roots of 3x squared. Abso-freaking-lutely. Good job. Good job. Because they have the same radicands, same index. How about E? Do they have the same radicands? Do they have the same index? So I got 5 cube roots of x plus 3 plus 15 cube roots of x plus 3. So what do I got in total? 20 cube roots of x plus 3. Excellent. Excellent. Does that make sense? May I continue? Yes? Thank you. Okay. What is the simplest form of each expression? Okay. They want you to add. And you're looking at this, and right from the get-go, you're probably saying, Mr. Morrow, none of these are possible. Why are you giving us such easy stuff? I'm not. We can simplify sometimes radicands, so that they can become like radicals. For example, the square root of 12, does that not break down into 4 times 3? So isn't this 2 square root of 3? Plus 75, isn't that 25 times 3? So that becomes 5 square root of 3 minus square root of 3. Now look at what we've done. We have converted them into like radicands. And they already had like indexes. So now 2 square roots of 3 plus 5 square roots of 3 minus the square root of 3 is 6 square roots of 3. Does that make sense? Everybody? Okay. Cube root of 125 plus cube root of 54 plus cube root of 16 minus cube root of 16. We're looking for cube roots to think of perfect cubes. Right off the bat, I always like to divide things by 2. So I got 125 divided by 2 here. What's the cube root of 125? Excellent, gentlemen. So that's 5 cube root of 2 plus. What cube root do you think I could take out of 54? 27. Thank you very much. Bless you. So that's 3 cube roots of 2. Do I have a cube root in 16? 8 and 2. Excellent. So this is minus 2 cube root of 2 because the cube root of 8 is 8. And now 5 cube roots of 2 plus 3 cube roots of 2 is 8 cube roots of 2 minus 2 cube roots of 2 is 6 cube roots of 2. It's actually quite easy, right? It's almost like fun. Almost like fun. Oh, well, I think it is. Like, you know, it's all a matter of perspective. You guys play Candy Crush, right? Okay. Well, I know a lot of you do. A lot of you guys play games that match things up and then blow up and look really cool. Think about this, guys. You are actually doing the math behind some of these games. And that's why I kind of love math, because there's a point to it. And these calculations that you're canceling out and combining together, there are advanced logarithms and equations that are built into these apps, into these games. And this is the math behind them. Not this exact math, but similar to this. They have equations that, you know, when you put the 3 colors together, the equations come together, the equations add like terms, and there's a solution. It's pretty cool. Sir?
Then can you make our quizzes like Candy Crush?
Can I make the quizzes like Candy Crush? You could pretend that while you're canceling out the radicals, it's saying sweet. You know, stuff like that. All right. All right. Yeah, it does, right? Delicious. Okay. All right. 14 square root of 20 minus the square root of 125. What's the square root of 20 break down to, y'all? 4 and 5, right? 4 times 5. What's the square root of 4? 2 times 14. All right, so I got 28 square root of 5 minus, that's going to break down to 25 times 5. Square root of 25 is 5. 5 square root of 5, so I've got 23 square roots of 5. Sweet. There you go. Does that make sense, my friends? Okay. 4th root of 32. Think of 4th roots. What 4th root do you think you could pull out 32? 16 and 2. Very good. Excellent. 4th root of 16 is 2, actually. So 2 4th root of 2 plus. Again, I could pull out another 16. 16 times 3. Oh, but we got a problem here, don't we? This is the, oh, wait, hold on. The 4th root of 16 is 2, but I've got the 4th root of 3. So although we did wonderfully in, bless you, reducing these, are they like radicands? So no, they have the same index, but not like radicands. So they're not like radicals, not possible. Not delicious. Okay? Next. See if we can break this down. I got negative 5x cubed. No. I got negative 5x times the cube root of 54x. Why am I doing it again? Let's break this down. What does 54 break down to? 27 and 2. What's cube root of 27? What's 3 times negative 5? So negative 15x times the cube root of 2 plus, what's the cube root? Oh, actually, is it 2x, right? Yeah, sorry. 2x. What's the cube root of x to the fourth? You pull out an x, so I got 7x, cube root of 2x. Guess what? Like radicands, negative 15x cube roots of 2x plus 7x cube roots of 2x is negative 8x cube roots of 2x. Does that make sense? Sir, talk to me. Got a question? No? We're good here, gentlemen? Okay. May I continue? Okay. Now, what is the product of each radical expression? We know how to multiply radical expressions already, but now we're just getting a little fancier. Now we're going to be multiplying monomials with binomials, and binomials with binomials, and monomials with polynomials, and binomials with polynomials. It's all like before. We're going to use the FOIL method, but this time we're going to be multiplying radicals. So we know how to do that, so don't freak out. Square root of 3 times square root of 6 times 3 is just 3 square root of 6 minus. Now pay attention to this. Square root of 6 times negative 5 square root of 6. I'm going to show you what's happening here, okay? You have the negative 5 square root of 6 times the square root of 6. But my friends, what happens when you multiply the same square root to the same square root? Cancels. Remember, square root of 6 times square root of 6 is square root of 36, which equals 6, correct? So just remember this. Square root of something times the square root of itself will always equal the inside radicand. Period. Does that make sense? So square root of 3 times square root of 3 is 3. Square root of 19 times square root of 19 is 19. Square root of x times square root of x is x. So in this case, what's the square root of 6 times square root of 6? What's 6 times 5? So I got 3 square root of 6 minus 30. Very good. Very good. And then I can go ahead and factor out a 3 and get 3 times the square root of 6 minus 10. Does that make sense, guys? Do I want it to go to the final answer? Please, yeah. Go ahead and factor all the way. Please, and thank you. Does that make sense, though, friends? Promise? Okay. Now, 3 minus square root of 7 times 5 plus square root of 7. FOIL. 3 times 5, 15. 3 times square root of 7 is 3 square root of 7. Negative square root of 7 times 5 is negative 5 square roots of 7. Negative square root of 7 times square root of 7. What do you think it's going to turn out to be? Negative 7. Thank you. Just learn it now so you save time. Don't do square root of 7 to square root of 7 is square root of 49. Square root of 49 is 7. It's wasting time. You know this already. Square root of something times itself, boom, get rid of it. It's the radicand. So now I add like terms. So I got 15 minus 7 is 8. 3 square roots of 7 minus 5 square roots of 7 is negative 2 square roots of 7. We're cooking here. Does that make sense, guys? And actually, thank you very much. You could factor out a 2. I was completely wrong. We were not done yet. Thank you, son. Beautiful. Spectacular. Next. C. FOIL. 3 times 2 is 6. Plus 3 times 4 square root of 5 is 12 square root of 5. 2 square root of 5 times 2 is 4 square root of 5. 2 square root of 5 times 4 square root of 5 is 8 times 5. Very good. So that's 40. 40 plus 6 is 46. 12 square roots of 5 plus 4 square roots of 5 is 16 square roots of 5. And actually, before I circle that, we could take out a 2. Right? Yeah, a 2. And then I got 23 plus 8 square root of 5. That makes sense. Now, for this one, please don't fall into the trap. The trap is this. Oh, this is 2 square root of 5 times 2 plus 3 square root of 2 times squared. Yay! No, that is wrong. Remember, when we had something like this, that was the same trap. A lot of people will make this x squared plus 4, and a lot of people would be wrong. This means x plus 2 times x plus 2. So, it means a squaring. Same thing up here, guys. This is 2 square root of 5 plus 3 square root of 2 times 2 square root of 5 plus 3 square root of 2. It's a FOIL. Or you could remember your perfect square binomials. Do you remember the form it should come out to be? What is it? A squared plus 2ab plus b squared. Fantastic. We'll do it both ways, but let me show you how knowing this helps a lot. Okay, so a is 2 square root of 5, right? What's that squared? Yeah, it's 4 times 5, which is 20. Plus, what's 2 times a times b? 12 square root of 10. Come on, guys. What's a times b? 6 square root of 10. Times 2? 12 square root of 10. Guys, are you with me here? Plus b squared. What's b squared? 3 times 3 is? And square root of 2 times square root of 2 is? So 2 times 9 is? So this would be 38 plus 12 square root of 10, factor out of 2, 19 plus 6 square root of 10. Believe it or not, that's the way to go here. However, a lot of times we forget that. So we'll do in red here the long way. Okay? No big deal. 2 square root of 5 times 2 square root of 5 is 4 times what's square root of 5 to square root of 5? Right? So that's 4 times 5. That's how we got my 20. 2 square root of 5 times 3 square root of 2 is 6 square root of 10. 3 square root of 2 times 2 square root of 5 is 6 square root of 10. Excellent. 3 square root of 2 times 3 square root of 2 is 9 times square root of 4. No, it's 2. Come on, guys. Get out of that already. Square root of 2 times square root of 2 is 2. That's what it equals. Now I got 20 plus 18. That's 38. Plus 12 square root of 10. Take out a 2. Factor it out, rather. 6 square root of 10. I don't care which way you do it, though. That's the beauty. And you know that about me. I'm not here to tell you got to do it my way. I don't care. Do I think that knowing the perfect square is quicker? Yes. But I've been doing this for a long time. Get used to it for a while first. Do it the long way if you have to. Then you'll see the beauty of knowing the formula. How are we doing with this, guys? Okay. May I continue? Thank you. Okay. This is... No. Let me pause for 1 second because I think I went a little too far with this. Hold on. Okay, guys, we're done. This conjugate stuff, we're going to learn in 9.6, so my bad, I should have deleted it. So thank you very much, and I hope you learned a lot. Have a great day.